Most factored form. The most factored form of a derivative is basically common factoring, but on steroids. So it's just a very much more complicated type of common factoring. The first thing you have to know is how to set yourself up so that you'll be able to common factor it. The best thing you can do is to move coefficients to the front and functions to the middle with rational exponents, writing it as rational exponent form. So for example, on this first one where I say set up, so right here, I have this expression. You want to move the coefficients to the middle, so 3/5, or sorry, coefficients out front, and then the functions to the middle using rational exponent form. So instead of the square root of x squared plus 1, write it as x squared plus 1 to the 1/2. Then the x minus 3 squared on the bottom, move that to the middle, so it becomes x minus 3 to the negative 2. I'm moving it from the bottom to the middle. Middle means the same as the top, so now it's going to have a negative exponent. So what I'm doing is running through right now just some little sub ideas that you have to use in order to factor. So first thing is to set yourself up in each term. Next, you have to know what you would common factor out. So what's your GCF, your greatest common factor? When you have functions that are in common, you pull out what's to the lowest exponent, the function to the lowest exponent. So for example, on this one, you're going to want to pull out, they both have an x plus 3, so you're going to want to pull out for your GCF an x plus 3 to the negative 2, because that's the lowest exponent. For coefficients, numerators work differently than denominators. For numerators, you do what you typically do, which is to pull out whatever the greatest common factor is. So for example, on this, the numerators are 4 and 8. You should pull out a 4 because that's what's in common. But the denominators are a little bit different. For the denominators, you pull out the common denominator. So between 3 and 9, that's of course 9. So now let's use that idea. Now let's put all three of those ideas together in order to common factor this, or to get its most factored form. So we have this expression. The first thing we should do is set ourselves up. So it's got to be 4/3 x plus 3 to the negative 2, and then plus 8/9 x plus 3 to the negative 1. Okay. Next, we talked about what the coefficient you would be that you would pull out. Between 4 and 8, what's in common is a 4, and for the common denominator between 3 and 9, it's a 9. The only function that they have in common is not x, but x plus 3. The second term doesn't have an x to pull out. So we'll take out x plus 3 to the negative 2. That's the lowest exponent. So what's left over? So when you common factor something out, you're using division. Okay, so for example, off to the side here, if I gave you 6x squared plus 9x, what would you have common factored? You would have common factored a 3x, then you would get 2, because 6 divided by 3 is 2, but then you would get x, because you would subtract the exponents. 2 minus 1 is 1. And then on the second term, you'd be left with plus 3. So we're going to use that same idea here. When you have 4/3, when you divide it by 4/9 on your calculator, you end up getting 3. You didn't pull out the x, so that's still there. Then you pulled out an x plus 3 to the negative 2, so that's gone. On the second term, you have 8/9. Divide that by 4/9 on your calculator, and you get 2. You pull out an x plus 3 to the negative 2, you pull that out of an x plus 3 to the negative 1, and you do that by subtracting the exponents. So negative 1 minus negative 2 is the same as negative 1 plus 2, so you get x plus 3 to the 1. Now, you simplify what's left over within the square bracket. You get 4/9 x plus 3 to the negative 2, and then 5x plus 6. Okay? Then you're pretty much done now because you can't common factor anymore. So you move everything to the correct floor. So you get 4 and 9, that's your coefficient that's setting your floor. The 5x plus 6 will be up top, and then the x plus 3 to the 2 will be on the bottom because of the negative exponent. Let's try another one. So this root expression looks pretty complicated, but there are no coefficients, it's just 1. So basically just move everything to the middle. And change it to rational exponent form. So you'll get x to the negative 1/2 from the bottom guy, and x plus 2 to the 1/2 from the top guy to the 1/2. From the second term, you'll have an x to the 1/2, and then you'll have x plus 2 to the negative 1/2 because it was in the bottom. What's in common that you pull out? They both have an x and an x plus 2, and the lowest exponent on them is the negative 1/2. So you'll pull out x to the negative 1/2, x plus 2 to the negative 1/2. What's left over in the expression? Well, when you pull out the x to the negative 1/2, obviously that's gone. When you pull out the x plus 2 to the negative 1/2 out of the first term, you subtract the exponents. So you keep the base and subtract 1/2 minus negative 1/2, that is just 1 whole. Then, from the second term, you do the same thing. The x plus 2 is gone, but you get minus x, because again, 1/2 minus negative 1/2 is the same as 1/2 plus 1/2, which is 1 whole. We can simplify within the square bracket, and you can see that the x's will cancel out, leaving us with a 2. So the final answer on this is 2 over, because the 2 still stays up top, and you get root x on the bottom and root x plus 2. Those should both move to the bottom because they both have negative exponents. Finally, on the last one, it's a big one. So let's look at, they both have an x plus, sorry, this is a little bit messy on this. Let's clean that up. They both have an x, or all three terms have an x plus 1, and a 2x minus 3. So you got to pull out all of those. Instead, I'm going to change this. Instead of rewriting it, I'm going to change that to the 1/2 and change this to the 1/2. Now everything's in rational exponent form and in the middle. Let's start with the coefficient. The coefficient on this is the numerator. We have an 18, 9, and a negative 18. What's in common there? A 9. The denominators are 1, 2, and 1. What's the common denominator there? It's going to be 2. They all have an x. The lowest exponent of x is x to the 1. They all have an x plus 1. The lowest exponent on that is x plus 1 to the negative 1/2. And they all have a 2x minus 3. So the lowest exponent on that is 2x minus 3 to the negative 2. Now, we'll common factor, or by division. When you type in 18 divided by 9 over 2, you get 4. You pulled out an x plus 1 to the negative 1/2, making this x plus 1 to the 1 whole. Then you did negative 1 minus negative 2 on the 2x minus 3 function, and you get 2x minus 3. On the second term, you pulled out the 9 over 2. You pulled out an x, so now you're still left with an x. You pulled out an x plus 1 to the negative 1/2, and you're left again with another 2x minus 3, because negative 1 minus negative 2 is 1. When you pull out a 9 out of 2, or 9 over 2 out of the negative 18, you're left with a minus 4. You pulled out an x. You pulled out an x plus 1 to the negative 1/2, so we're left with x plus 1 to the 1 whole, and the 2x plus 3 is gone. Now you can simplify within the square bracket, and you can do that by expanding and simplifying. So I'll keep the outside, or the out front. I'll just recopy that because I'm not going to work with that yet. But on the inside, so I should expand and simplify here. X times 2x is 2x squared, times 4 is 8x squared. X times negative 3 is going to be negative 3x, times 4 is going to be minus 12x. Follow the process for FOIL, and you'll end up getting a 8x from that distribution, and a negative 12 from that one. You'll get a plus 2x squared minus 3x minus 4x squared minus 4x. When you simplify this here, you end up getting a 6x squared minus of 11x minus 12, which lucky for us doesn't factor. So that's going to go in the place of that large bracket. And now we'll put everything on the correct floor. So the x is a positive exponent, so it stays up top. The x plus 1 goes to the bottom as a root. The 2x minus 3 is going to go on the bottom. And the 6x squared minus 11x minus 12, that'll stay up top. And that is the most cleaned up and most factored form of that derivative.